Hey guys, this is Anton Man back again with another new video. So in my last video I covered the Mockvita 2020 second question. Now I will cover the Mockvita 2020 third question, which is collision course. Got a huge positive response in my last video, and there were several comments telling me to cover this question, and I also wanted to cover it. So let us do it. So firstly, the question name is collision course, and let me first read out the problem statement for you. So, on a busy road, multiple cars are passing by. A simulation is run to see what happens if brakes fail for all the cars on the road. The only way for them to be safe is if they don't collide and pass by each other. The goal is to identify whether any of the given cars would collide or pass by each other safely around a roundabout. And the roundabout is a reference point O, which is origin having the coordinate 0, 0. But instead of going around it, cars pass through it. So the question is based on coordinate geometry, as I understand, because basically you are given an origin 0, 0, and you have given several coordinates, such as x1, y1, um, then x2, y2, and in this coordinate, your card is there in this coordinate. So and the basically the input is, let me check the input. The input first line contains C, the total number of cards, and the next three lines will have, three space delimited values. The first being the x coordinate, the y coordinate, and the velocity v. So just think, if you have the x coordinate, if you have the y coordinate, and the velocity v, rather only the x and y coordinate, and we have also the origin, that is 0, 0. We can easily find out the distance from between the car and the origin. And if we get the distance, we have also have the v, which is the velocity, so we can easily find out the time from it, right? So the main focus of ours is to just get the distance. If we first get the distance, we already have the velocity, so the time will be distance by velocity, or rather speed. uh, so the time is equal to distance by speed. So now we need to calculate the total number of collisions. So a collision will only happen when two cars or more than two cars reach the origin at the same amount of time, or at the same time. Okay, so if one car takes 13 times to reach the origin, and the second car also takes 13 seconds, or for example 14 seconds to reach the origin, and another car takes 14 seconds to reach the origin, then both the cars will collide. So basically we need to calculate all the time taken for all the cars to reach the origin, and we need to store it. Okay, so we can describe this problem very well using this diagram. So we have the coordinates of all these cars, and that origin is given here. So we will just need to find out the distance from this point to origin, this distance of. So what we need to do is uh, distance of this point to origin, distance of this point to origin, okay, distance of this point to origin, distance of this point to origin, and at last distance of this point to origin. Okay, so if we get these distances, we will get it. Suppose getting this distance, so we can get the distance from a formula. I will show you the total distance formula from the coordinates. So we need to find all these distances to the origin. Okay, so we need to find all the distances to the origin. So now we have a formula, as we know, distance from x2 comma y2 to x1 comma y1 is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so it's pretty simple. But it gets even simpler because we are given the origin, not any other point, the origin. So this formula for origin will be reduced to only square root of x2 whole square plus y2 whole square, because the x1 comma y1 is 0 comma 0. So through this we have, as we know in the problem, we will be given the x coordinate with the y coordinate. So finding out the distance will be pretty easy. So let us start writing the code for it. Firstly, we need C in C and C in C, the total number of cars. Now we will make a structure. The structure will contain the x coordinate, the y coordinate, and obviously the distance speed. So we'll store that all the cars in a structure. We will make an array of structure. Let's just first make a structure. Struct car. We will have long int x, long int y, and we will have long double speed s, or rather v. We will use long double v because square root generally returns a double data type, and when we need the distance and we're calculating the time, it will be beneficial for us if we use double, if you use v as double. So that's why we will use long double v. Anyways, now we will take inputs of all the cards. So for that we first need to make a array of structure. So we'll that struct card, let name the array as a, and it will have a size of c plus 1. Okay, now we will take all the inputs. So for int, simple for loop, for int I is equal to 0, I less than c, I plus plus, c in ai, the first card x value, then c in ai dot y value, then eventually c in ai the v value. Okay, it's pretty simple. We are just taking the inputs, as we know, as in the question also we need to take 3 inputs, which is the x, y, and this velocity v, and we are taking 3 inputs, that is x, y, and the velocity v. So this part of the job is done. Now for each input we need to calculate the time. So if you want, you can take a variable of long double distance and time in the struct card, but we don't need it because we only need the time for each card, and we will then store it in a hash map. Why hash map, you say? So let me give you an example for the sample input. So 5, 12, and 1. So suppose the coordinates are 5, 12, and 1, and another is 12, 5, and 1. Okay, there are 2 coordinates, 2 cards. So the time taken for the first coordinate, which is this 5, 12, and 1, to reach the origin will be, firstly we need to find the distance. So distance will be simple, that is square root of 5 square plus 12 square, which will give us square root of 169, which is 13. Okay, so the distance will be 13. Simple enough. So if we get the distance and the velocity given is 1, so the time taken will be time is equal to 13 by 1. Similarly for this problem, we will same also have the distance, we will have square root of 12 square plus 5 square, we will have 13, and the time also will be 13 by 1, which is 13. So both this card reaches the origin at the same time, that is 13. So if you have a time of key time as key, that is 13, we will increment it for the number of cards which have the same value of time. Okay, so for that we will have a hash map, and the hash map key 13 will be a key for the first card. If it is a it takes 13 seconds to reach the origin. Let's not talk about seconds because I don't know the unit. So let's 13 units to take reach the origin. So firstly with the hash map we'll have 1. Then if another card takes 13 seconds to reach the origin, the hash map will have 2. And simply if there are n cards which reach the origin at 13 seconds, we will have n. It's pretty self-explanatory and it's easy. So we will now make a hash map, which is in C++ an unordered map, unordered underscore map. So the key will be a long double, because time will be double, and the values will be int. So we will map long double to int, and let me name it as time. Okay. So we for any time the card text to reach the origin, we will include it in the hash map. If the time is already there, we will increment it. Otherwise, we will make another key and we will include it in the hash map. So for that, we need to traverse the array once again. Traverse the array of structure. So we'll traverse it simply once again. For int I is equal to 0, I less than c, I plus plus. Okay. Now we will calculate the distance. So for the distance, as I already showed you this formula, which is square root x2 whole square plus y2 whole square. So first we need a variable called distance. Long double distance is equal to sqrt. Now we will use the pow function here to get the square. So we'll have pow, and pow will take the first card's x variable, so that is ai dot x, or a0, since I is 0 now in the first iteration. So a0 dot x will give us the first card's x coordinate. So we will have ai dot x. Okay, and we need the power of that 2, so 2. Again we will just add the first card's y coordinate, so that will be pow again ai dot y and the power of 2. Okay, done, and we have an squarity of the whole thing. So this we will get the distance. Now we will get the distance. We already have the velocity or the speed, so let us take the time. So long double t is equal to we will calculate it as distance by velocity. So distance by, we have the velocity of this car, or the speed of this car in ai dot v. So we will write simply ai dot v, and now t will contain the time taken for the first car to reach the origin. Okay, so we can write we can comment it out for the further understanding. X coordinate of the card, y coordinate of the card, and speed of the card. Now we will just simply include this t in our hash map. So what is simple, we'll write the name of our map, which is time, the key is t, and we will increment is plus plus. In C++, the time always the values are initialized as 0, so we don't need to think about any other stuff. We'll just increment it. So now we have got this, our hash map is ready. Okay, now we need to find out the total number of collisions. As you can see, which is the tricky part here. Here A and C and B and C collide. This means A, B and C both reach. So in our diagram we can see. So A, this, let us take this as A, this is B, and this one as C. So both these cars reach the origin at the same point of time. But we will count the collisions separately. We will not count this all three cars colliding at one. We will not count it. So A, this will collide with B. Let me write it out for you. So A will collide with B, A will collide with C, and C will collide with B. So there will be separate three collisions. So for this we have a formula in maths, a very common formula, which is NC2, which is generally n factorial by 2 factorial by n minus 2 factorial. But as you can see, n can here be very large, but if you use the naive approach of calculating the factorial, it will give us runtime error, so we can't do that. So here we will generally use another formula to reduce this NC2 without using the obviously factorial. It gives us n into n minus 1 by 2. So we will get n into n minus 1 by 2, and we will use this formula. So for that we won't need to calculate the factorial. We will only use n into n minus 2 by n minus 1 by 2, and we will get the total number of collisions. So first, let us first take a variable which will hold the total number of collisions. So long int collisions is equal to 0. Now we will traverse through the whole hash map, and the t value at different t's will be the n, and then we will simply get the total number of collisions from it. So we can check with the sample inputs the time we get for each card to reach the origin. So let me print out here only. See out the time taken for this card to reach origin is space, then we will have t, we'll have a space, then we will write t t seconds, t units rather. Okay, I will end l. So let me check it. Let me once check it with my sample input output. So let me save it. We will have Mockvita underscore 3 2. Okay, 3 2. I already solved it during the contest, that's why. Now let us take the sample inputs once. So we will have 5. We have 5, 12, 1 coordinates. We have 16, 63, 5. We have minus 10, 24, 2. We have 7, 24, 2. We have minus 24, 7 and 2. So our code is working fine. So this the time taken for this card to reach the origin is 13 units. The time taken for this card to reach the origin is 13 units, and this is also 13 units, 12.5 units and 12.5 units. As you can see, our output, we have not yet gotten the final answer, but our output matches. Here A and B in the explanation, A and B collides, and they will definitely collide because A and B both have the same time. Similarly, A and C collides, so definitely A and C also at the same time, and B and C collide because B and C also have the same time. Similarly, D and D collide because D and D both have the same time. So here our hash map generally should contain 13 as a key will have 3, and 12.5 as a key will have 2. So our hash map will contain this. Okay, now for the total number of collisions. So we will now traverse through the whole hash map. For that we will use the auto keyword. For auto, I is equal to the name of our hash map is time dot begin, I not equals to time dot end, and plus plus I. Okay, now if the value of a key is 1, we no need to consider it for our calculation, because if only one card reaches at origin with a particular time, then it won't collide with anything else, right? So it won't collide, so we don't need to consider that. So we'll only write, so if we write that if I dot second not equals to 1, we will only consider all those cases. So here in C++, I dot second gives the value and I dot first gives the key. Okay, so if I dot second not equals to 1, we'll consider it. So we will have a long int val is equal to I dot second, the value of that key, into I dot second minus 1. As I discussed, we are doing it as I discussed of n into n minus 1 by 2, which will give us nc2 by 2. Okay, so we'll keep this inside another bracket. So we will have the value of total collisions for each time interval. And now we will just include this in our collision. So collision variable plus equals to val, and in this way we will get the total number of collisions of the question, and the question is pretty much solved. So let us test again. We will see out collisions and L. Yeah, so we will check. We will run it. Sorry, I think I'm getting a mistake. Error expected. Acha, we are getting an extra. Yeah, sorry for the error. Yeah, now we will check with the sample input output. So we have first 5, then 5 1 2 1, we have 16 63 5, we have minus 10 24 2, we have 7 24 2, we have minus 24 7 and 2, and so as you can see 13 13 13 12.5 units, and the final answer is 4, and also the output is 4. So we are getting the right answer, and our logic is working fine because we are getting the slim explanation here. Our logic is directly related to the explanation, so we can comment that out. We don't need that in our final answer, so comment that out. So this is the code. So guys, hopefully you liked it. Sorry again. Hopefully you liked it. Hopefully you liked my understanding. I showed you how the actual code works in the coordinate geometry. I showed you how to find out the time taken. I showed you how to get the NC2, because if you calculate and the factorial using the factorial method or a function, it's gonna cause problems. It will give us a runtime error, because as you know factorial increases were large. So even if a value of 40, we can't hold it in a normal data type, so that will give us a runtime error. So that's why we'll need to use n into n minus 1 by 2, and hopefully this clears a lot of things for you. Hopefully you like the video. Please do subscribe, or rather like the video if you like it. Do share it with your friends who are interested in competitive programming or who are going to appear for CodeVita 2020, and do comment about the stuff you didn't like or want anything to clear me out. I'm also learning. I'm also in a learning phase, so I might make mistakes. So do comment out. It helps me a lot. It helps me to learn even more. And do share the video. Do subscribe to the channel if you like it. That's all for today's video. Bye bye.